Please, you can unmute yourself now. Please, you can unmute yourself.
Okay. Assalamu alaikum.
Alaikum salam wa rahmatullah. How are you?
Good day, doctor, and thank you for this presentation.
Yeah, welcome.
So I was thinking of something. Maybe when you do feature selection, will it make you to lose some of your points? Because I was thinking maybe when you do a feature selection, you remove some features, then the experimental conditions could be maybe the same for point 1 and 2 because you removed one feature, which was the difference between the two points. So I was wondering, will that make one of them be a replication of the other, or each of them will serve as an experimental point itself?
So thank you for the question. Sorry, to what the later part of the question, I didn't get it clearly. It seems your voice was breaking. So can you just come again, please? Yeah.
Okay, so let's say we have experimental points. Maybe we have 3 variables.
Okay.
And then we wanted to do a feature selection.
Yeah.
And we removed the 3rd variables. But then maybe the 3rd variable is the difference between actually 2 points. Maybe you have 2 points at the same experimental condition, but the 3rd point is the only difference. Okay. When you remove the 3rd point, then the 2 points become kind of the same. So will that make one of them a replication of the other, or each of them will serve as an experimental point itself?
Okay. Now, I hope I get your question very well clearly. Well, actually, as a matter of fact, you see, when you're dealing with machine learning or data mining or data science, as the case may be, you see, yeah, we can get the data set from the experiment. We could get the data set from the experiment. But however, once we bring in the data, we let the data speak. That principle is very, very important. We let the data speak. Now, so sometimes we have to assume we don't know the background information about this data sometimes, because that could actually mislead us to getting the right thing we want. So, for example, when you get in your data, say X1, X2, X3, as the case may be, so you have the output, which is the Y. So get the sample to the model and then start your feature selection process. Like I said, there are several feature selection principles you can use. You can use the multivariate, which means you want to investigate multiple features together at a time. How is these two performing together? How is these two performing together? Or you want to check each of them separately. Is X1, X2, X3? So the advantage of a multivariate, sometimes we can use to detect some redundant features, because sometimes some features are redundant. For example, I have a feature, this is date of birth. This is date of birth. The second one is age. So without anybody know that date of birth and age, you get age from date of birth. This is a redundant feature. Though there are some other claims, some other application whereby we might need different similar information. For example, when we build in ensemble, we might want to use date of birth to build ensemble one machine individual model, and use age for another one. Although you were using them in a different manner. One is showing the year, the date, and then the month, while the other is just showing ordinary numbers. They could have implication in some modeling. But if the two has to be for only one model, then this is redundancy. We might easily be able to do that. Even at that, let the data speak that, oh, this data is not contributing anything serious to us. Because if you have redundant data, X1, X2, they are going to count as number of features. And remember, the more the number of features, then the exponential growth in the number of samples is going to be the big issue now. So you can't afford to put redundant feature. However, once you have the data, let the system actually speak for it. So sometimes we don't of course, we cannot just throw away our own knowledge of that area, but let's the data set tell us that, okay, even though X1, X2, X3, they are connected one way or the other, but if the system realize that in most cases, if the data set is at that, it will also detect the same thing. But we have seen situation, I'm saying it because we have seen situation whereby engineers, especially in the drilling operation, there are like 5 variables or 5 features they usually monitor. They felt that 3 of those variables are very, very important. So they will be monitoring those 3 and using it to determine their drilling direction, drilling rate, and some other things. But later we realized when we had data that the 2, based on their own knowledge of engineering, it was so convincing when they said, no, those three are the best. The other two are not really very important. But when data mining or data science was used, we realized that one from this neglected one plus one from these three will perform better than whatever the other ones will perform. Just imagine, just one from they were ignoring two features before, using the best three according to the knowledge of engineering they had. But that feature selection was able to identify that one from here and one from these three, combine those two, they get the best result possible. Actually, they were surprised because that was against the engineering, maybe kind of knowledge they've had from experience and the like. So that's why sometimes letting the data speak means we might have to shake tables sometimes. Shake tables. It means you might need to do something that has not been done before. It might be strange to people that are working that area that, no, we never do this before. But then let them go and try it and then see, perhaps maybe it's going to work better. Because we build on what we know to be correct. This is natural. Human beings, this is the way we work. But actually, data science is taking it to another level that, okay, let the data speak. Sometimes we have been using a particular method, a formula, an idea, based on the information that we read in our textbook or what we taught or what we also practice. But however, things are changing every day, especially when it comes to human modeling, like medical applications. The kind of food we are eating these days is totally different from the food our fathers were eating, either because of the modified foods and so many other things that could be responsible. You see? So based on that, what we know to be the case before, our data might actually speak in opposition to it. It might say, okay, remove this feature, they are not very important, even though they were known to be the best feature before. So let the data speak, let us try it out, go and practice it and see if it's going to be okay. So with machine learning, we have to have a flexible mind and then have some little trust in that data, in as much as we can use it in real life, and it's showing that, yeah, what is suggested is actually also okay. So I hope I answer your question with that.
Yes, doctor. Thank you very much.
Barakallahu feek. So, Mr. Isaiah, Dr. Isaiah. The next person raising hand is Dr. Isaiah. Are you there? Okay. Then Mr. Sefiu Adewi. You need to unmute yourself, please, in case you are talking, but we are not hearing any one of you.
Okay, Prof. Good morning. Can you hear me?
Yeah, I can hear you. Good morning. Who is talking now?
Yeah, Isaiah is speaking, Prof.
Okay. You are welcome.
Yeah, thank you, Prof.
Okay, welcome.
Yes, my question, though, I have mixed some lecture. Maybe my question will have been tackled sometimes ago. I don't know.
Okay.
Now, assuming that you have a kind of data set,
yeah,
whereby we have attributes that has strings, we have numeric, and at the same time, a kind of a networking data whereby it may be very difficult even to read. Now, my question is this: I know in one of these lecture you actually spoke about a pre-processing before the feature selection. I don't know if such has been treated earlier, Prof. If you can direct me to that very particular lecture so that I will study, because I have a challenge of how do I convert the attribute into a particular a particular format. Do I need to change everything to numeric, or do I need to change everything to string before the feature selection? Or in such a situation, what can one do? I don't know if you understand. You get my question,
Yeah.
Prof.
Yeah. That's so clear. It's clear. Thank you very much.
Thank you.
Yeah, well, regarding the data set, generally, it depends on the area and the platform you are using. Okay. Again,
Yes, Prof.
this is one of the advantages. I can say one of the advantages of platform like Weka, because Weka actually can take a lot of different type of data set samples. I mean, different types of format for your data, as the case may be. Whereas in some programming formats, I mean, if you are using for formats of programming contest platforms, you might have to convert the data set to numbers. In that case, you need to sit down on the data, try to study it. Okay, what are the representation I can use? For example, if it is they wrote male or female, then you have to code it. Okay, male means 1, female means 2. And that code needs to be unique across your features. That is if it is needed. So depend on the platform actually that you are using. Some platform, either is string or whatever, once it's going to study the uniqueness of it and it's going to work with it in some platform. While some platform, you need to look at unique ways that you can code each of those strings. You can then convert, either make it to be number or make it to be unique categorical, as the case may be. So it depends on the data set actually that you have, but for sure, some platform allows you to use your data as it is. Even if it is network data, they will allow you to run it as it is. And you can even still run feature selection on them, because they are going to also, if they can recognize it to build the model, the same platform will recognize it to be able to rank them according to the contribution they are making. So it depends on the platform that someone is using. But for sure, sometimes you might have to look at the data and then look at, okay, how unique is it? Do I need to code it using a number or using particular categorical values, or as the case may be? So it depends on the particular data set that you are talking about this time around. And if there's any special, you can refer to our feature selection and also pre-processing method. Yeah, I believe there are videos on pre-processing method, different methods you can pre-process your data. Check them out. So if yet it doesn't cover your specific data type, please don't hesitate to contact me, okay? You can private chat me later, and then me have a look at your data. Maybe I can be able to provide specific guide for you in that particular scenario. Hope that clarifies. Hello.
Yes, Prof. Yes.
Okay.
Thank you, Prof.
Okay, you're welcome. Yeah. Okay, I think so. I think those are the questions we have for today. So once again, thank you very much. So for the attendance, we wish you all the best.